Okay, today we're going to talk about section 4.3 Determinants and Cramer's rule. First off, I want to state that only square matrices have determinants. We're going to take a look at a 2 by 2. Of course, a 3 by 3 will be later on in the lesson. So, we'll notice that the distinction between a determinant and a matrix is going to be the absence of the little what I'll call dog ears on this. So this looks like a big absolute value symbol, and it refers to the determinant, and the determinant is a value, a number, whereas a matrix is an array of numbers. This equals one number. It's a process. So if given a 2 by 2 and we're just putting in letters A, B, C, and D, the way you find the value of this 2 by 2 determinant is on this upper left to lower right diagonal. You take those two numbers, A and D, and you multiply them and subtract, and it's always subtract. You take the from lower left to upper right diagonal, B times C, and whatever you get from those is going to be the answer. So working this out with numbers now, let's put in 1 for A, 3 for B, 2 for C, and 5 for D. We would say to find the value of this, and again it looks like a big absolute value symbol. It's not. It's a determinant. It's different from the different from the matrix. It doesn't have the dog ears. Okay, so it's 1 times 5 minus 2 times 3. 1 times 5 is 5. The minus comes down. 2 times 3 is 6. The value of this determinant is -1. All right, you go ahead and try this one. I'll stop the video. Okay, so we should have come on this diagonal here. We should have said 1. Let's see here. Okay, so it should be on this diagonal here. 7 times 3 will give us 21. It's always minus, and going up 2 times 2 will give us 4, and 21 minus 4 is 17. Okay. Try this one. Again, multiplying on the diagonals, -7 times 2 gives us -14. It's always subtract. The diagonal going up, -7 times 11 gives us -77. Well, that's going to become plus a positive, and there is going to be 63. Okay, that's finding the value of a 2 by 2 determinant. All right, let's take a look at 3 by 3 determinants. A 3 by 3 determinant looks like this. It has 3 rows and 3 columns, or the horizontal groupings is 3 and the vertical groupings is 3. Okay, it is a determinant. Okay, so excuse me, this is a matrix again, and then this is a determinant. And of course, the difference again, I've already been over that, is the dog ears, or what I'll call these little pieces up here are missing. Okay, it's an array of numbers, and this determinants are found through a process, and it's equal to a number. All right, here we go. Gonna find finding a 3 by 3 determinant. Now, the 2 by 2 is a pretty simple process. The 3 by 3 is a little more complicated. Step 1 is to make a 4th and 5th column by repeating the 1st and 2nd columns. So, again, in our determinant that has just letters in it, I've gone ahead and designated this as column 1. And this is column 2, and this is column 3. So if you want to find the value of this, the first thing that we would do is take column 1 and repeat it here, A, D, and G. That made a 4th column. And then we take the 2nd column and repeat it as a 5th column. Okay? All right, in the next steps, we will change letters to numbers to better understand the process. So down here, in other words, I've let A equal 2, I let D equal -2, and so on. So now I put some numbers in this instead of letters to better understand the process. So step 2 is to multiply. Left the L out here. Multiply on the diagonal, on the 3 diagonals going down, and add those products. Okay, so as you arrange these 5 columns, you'll notice that the first diagonal that has 3 in it is this one right here. Now this is a diagonal, but it has only 2 numbers in it. Consider this a diagonal, but it really isn't. So we take the 3 diagonals that have 3 numbers in them and we multiply them. So we're saying 2 times 0 is 0 and 0 times 4 is 0. It's always add. Do the next column. -1 times 1 is -1, and that times 1 is -1. It's always add. 3 times -2 is -6. -6 times 2 is -12. Now we add these 3 numbers up. So 0 plus -1 plus -12 gives us -13. Now that's like the same thing in that first 2 by 2 where we had that diagonal going down. That number goes in front. It's always subtract. Now we do the diagonals going up. So step 3 is to multiply the 3 diagonals going up and add those products. So 1 times 0 times 3 is 0. 2 times 1 times 2 is 4. 4 times -2 times -1 is +8. 0 plus 4 plus 8 is 12. And the final answer comes from -13 minus 12, or -25. Okay? So that's the value of this determinant right here. Again, it is equal to a number. It's equal to the number -25. Okay. Now, when you're doing this multiplication and addition, most of my students have calculators. You can just plug that into the calculator and let it do the hard work for you. All right. Go ahead and find the value of this determinant. I'll stop the video. Okay. Coming back to it. First off, we're just going to copy down the first 3, just like they are. We repeat the first column, making a 4th column. So we'll repeat 4, 5, 1. Repeat the second column as a 5th column, and that's all the repeating we do. The next thing to do is we look for the diagonals and we multiply these products. So let's hope we can make it through this. 4 times -7 is -28. -28 times 2 is -56. Between these is always a plus sign. The next diagonal going down, since it has a 0 in it, I know the answer is going to be 0. I don't have to work the rest of that out. Then the third diagonal going down, 1 times 5 is 5. 5 times -2 is -10. And then we add all these up and we get -66. And that goes in front. With a subtraction sign, now we do the diagonals going up. So here we go. There's a diagonal going up. 1 times -7 times 1 is -7. It's always plus between the diagonal products. There's a 0 in this one, so it's going to be 0 plus the third diagonal going up. 2 times 5 is 10. 10 times 3 is 30. Okay, getting a little sloppy here. And -7 and 30 is 23. And so that number goes here. 23, and -66 minus 23 is going to be -89. Okay, hopefully you came up with that. Let's take a look at one more. Okay, putting these numbers, copying over column 1, column 2, column 3, repeating column 1, repeating column 2. Diagonal products going down. 12 times 3 times 1, 36. Always plus between the diagonal products. Next diagonal going down. 4 times 2 is 8. 8 times 5 is 40. Always plus between them. Third diagonal going down. -1 times -2 is +2, and that times 8 is 16. Okay, got to add all this up, so we have 76, 86, and 6 is 92. So it's going to be 92 minus, now we figure the diagonals going up. 5 times 3 times -1, -15, plus between them. 8 times 2 is, let's see, that's going to be 16. I think I'm going to do 24 times 8, and I don't want to do that in my head. I'm just going to do that over here. That's going to be 192. And the third diagonal going up, it's going to be negative 8. So we're going to have 192 minus 15 and 8 is 23. So we're going to have 9, 169. Okay, and 169 minus 92, and that's going to be 7. So we get 77 for our answer. Okay. All right, now let's talk about Cramer's rule. Cramer's rule is used to solve systems of equations. Okay, and so here's our system of equation right here, and I've conveniently marked the coefficients of the x in a certain color and the y's in a certain color, and I'm going to call these the constants over here, but the problem that we're going to get is not going to be color coded, but this is sort of to help our understanding. Okay, so if we want to solve this, then Cramer's rule, you have to find the value of 3 different determinants and you have to set them up. We start with the first one called the D determinant, and it's made up of the x column and the y column, or just take the coefficients off of x and the coefficients off of y and put them in a matrix. This one I call the D sub x because as compared to the D, we substituted something for the x's, and you can see the constants come in where the x's were. In this one I now have the constants, so x is displaced, it's out here in the name, the constants replace x. That's what this is sort of telling us. And then D sub y, well, it's D except for we substitute the constants for y, so the y comes out and the constants go in, so it's the x's and the constants. Now to find these, you just find the diagonal product, so we have negative 32 and minus 10, and that's going to give us 22. Okay, here negative 8 minus a negative, which is going to be plus 50, and that's going to give us 42. And here we're going to have negative 80 minus 4, which is going to be negative 84. Okay. Next page. Cramer's rule states that the solution of the system is as follows, that the x-coordinate of our solution is going to be the d sub x answer divided by the d answer. The y-coordinate of our ordered pair is going to be the d sub y answer divided by the d. And if we had a system of 3 equations and 3 variables, the z would equal the d sub z over the z. Well, we didn't have one in this first problem. So in example 1, d was equal to negative 42. D sub x was equal to 42, and d sub y is 84. A negative 32 minus 10 is a negative 42, okay? I just caught that error. All right, so d is negative 42, d sub x is 42, and d sub y is 84. So we set our answers up. X is equal to the d sub x answer, negative 42, over the d answer, positive 42 over negative 42. And y is equal to the d sub y, negative 4, over the d sub answer, which is negative 42. 42 over negative 42 reduces to negative 1. Negative 84 over negative 42 reduces to 2, and we get our solution to the system, the ordered pair, negative 1, 2. Okay? Try this one. Alright, so working out d sub x, and d sub y, we get that. Our x answer is the d sub x over d, which is going to be 21 over negative 7, which gives us negative 3. And the y is equal to the d sub y answer divided by the d. Negative 49 divided by negative 7 is positive 7. Solution to the system, negative 3, 7. Okay? And just a reminder that this is just another way of solving systems of equations. We've done several ways. We've done solve by graphing, by substitution, by elimination, and now we solve by Cramer's rule. If we were to graph these two lines, just a reminder, they would intersect in one point at negative 3, 7. Okay, going to go on to example 2, and that's to solve a system that's 3 variables and 3 equations, and it looks like I've hid what these constants are, so I'm going to go ahead and write them in here. Somehow this has covered it up, so I'm looking over here. I can see what my constants are, so that's got to equal negative 2 here. Here's going to be negative 1. You can't see this, and I can't move this object here that I'm aware of, and that's going to equal 4. So these should be at the other side of the equal sign. Process is basically the same, it's just a little more involved. Okay, so we start out with making our, this time it's going to be 4 determinants, d sub x, d sub y, and d sub z. Alright, so we take the x column 1, 1, 3, and we write it in here, and the y column is 2, negative 1, don't forget to take the sign, and positive 4, 2, negative 1, positive 4, and the z column is negative 3, positive 1, negative 4. Okay, and here is the d sub x one, where we take the constants negative 2, negative 1, 4, and we put them in for x. X is displaced out of, it's in the name, it's out of here, we put the constants in its place. The d sub y, we take d and we substitute c for y, so it's the x, the c, and the z column of numbers, and they just plug in right there. And then to make d sub z, you take d and you substitute the z column for c, put c in for z, z is displaced out here. Okay, so let's go through this as quickly as we can. We repeat the first column on these, repeat the second column. Multiply the diagonal going down. 2 negatives, we got a positive. 1 times 1 times 4 is 4. Plus 2 times 1 is 2, times 3 is 6, plus negative 3 times 1 times 4 is negative 12. All that adds up to be is negative 2. It's negative 2 minus, diagonals going up. 3 times 1 times 3 is 9. There's 2 negatives, it's positive. 4 times 1 times 1 is 4. Negative 4 times 1 times 2 is negative 8. We have 13 and negative 8, which is going to be a positive 5. So we subtract 5 and we get negative 7 for our answer for D. Okay, doing d sub x. Yes, I know this is long. Some of you are saying that right now. I can hear you muttering. Okay, repeat the first, repeat the second column. Diagonals going down. 2 negatives is positive. 2 times 1 times 4 is 8. We always add. 2 times 1 times 4 is 8. We always add. Negative times negative positive. 3 times 4 is 12. We have 16 and 12. That's going to be 28. So this is going to be 28 minus the diagonals going up. Let's do those. 2 negatives positive. 3 times 1 times 4 is 12. It's always plus between them. 4 times 1 times negative 2 is negative 8, plus 2 negatives is positive. 4 times 1 times 2 is 8. We get 12. That goes in the back. We subtract. We get 16. Okay. Doing d sub y. Repeat the first column. 1, 1, 3. Negative 2, negative 1, 4. Diagonals going down. 1 times 1 is 1, times negative 1 is negative 1. Negative 1 times negative 4 is positive 4. Always plus. We have negative 6 on this diagonal. It's always plus. We have negative 12 on this diagonal. Okay. Negative 18 and 4 is negative 14. Negative 14 minus, diagonals going up. 2 negatives positive, 3 times 1 times 3 is 9, plus 4 times 1 times 1 is 4, plus 2 negatives positive, 4 times 1 times 2 is 8. We got 21, subtract 21, and we get, I don't want to be off the screen here, negative 35. Okay. All right, let's see. Do d sub z. 1, 1, and 3. 2, negative 1, and 4. Diagonals going down. 1 times 4 times 1 times negative 1 times 4 is negative 4. Plus 1 negative, all that's 6, it's negative 6. Oh, I can't hardly read that. Plus 1 negative is going to be negative 8. So I have negative 4, negative 6, and negative 8, negative 18. So it's negative 18 minus 3 times 1 times 2, 2 negatives, it's going to be positive 6, plus 1 negative, negative 4, plus 4 times 1 times 2 is 8. So that's 14 and negative 4, that's 10. And negative 28 is our answer for here. Okay. Let me go back and check this answer right here, because something tells me that I intended for these to be whole number solutions, and I certainly don't have enough room for my answer down here either. I've got to have 3. So let's check this one more time. We have, this should be negative times 8 is negative 8 here. Okay, so I thought I'd find a little error in this one. So let's erase this. And erase this. And this. And so we're going to have positive 12 here. Okay, so we have 12 minus 12, or 0 for this one. Okay. All right, so now we're down here to set up our answer. X is equal to the d sub x over the d answer. I should have written that in here. I didn't. So d sub x over d is going to be 0 over negative 7. Well, that's going to be 0, isn't it? This is going to be d sub y divided by the d answer. Well, d sub y is negative 35 over, make that a 5 rather, over negative 7. Negative over negative is positive. That's going to give us 5. And then z is going to be the d sub z divided by the d answer. D sub z is negative 28. D is negative 7. We come up with positive 4. Solution to the system, 0, 5, 4. Yes, that's a lot of work. That's how you do it with 3 variables and 3 equations. Okay, here's one for you to do, and I'll give you a little time. Alright, didn't talk through this one to try to hurry it up. I know this is a long process and I didn't want to slow myself down by talking, but we find out that our x-coordinate is 2. Y is equal to d sub y answer over d. 0 over negative 4 equals 0. And the z-coordinate of our ordered triple is going to be the d sub z answer divided by the d answer, which is going to be negative 4 divided by negative 4, or 1. So we wind up with the ordered triple 2, 0, 1. Okay. That concludes the video. Thank you for watching. See you next video.